Hello, on this video, we're going to do a quiz on integration with trigonometric substitution. So if you need to review trigonometric substitution, go ahead before you start this quiz. So what we're going to do, our integration now has boundaries from 0 to 1, and then we have to take the integral of 5x cubed square root of 1 minus x squared dx. So what we're going to do is use this special trig substitution. The square root of 1 minus x squared is very similar to this, right? So our a value is going to be, so we have a constant squared minus x squared. So our a value is 1, because what number 1 squared gives you 1? 1, right? Yeah. Oh, okay. Here, actually, let me, uh, yes, let's use this pencil. I'm not going to use I won't use the other pencil. I like this one. So yeah, we're going to use square root of a squared minus x squared. So my a value is definitely 1. So we're going to use this identity. A equals a times sine theta. And we agreed that our a value is 1 because what number when squared gives you 1? 1. Okay, so what do we need? Well, we have our x, we need an x squared, we need the x cubed, and we also need the dx. So let's find those out real quick. So x squared is basically squaring 1 since theta, so that would be sin squared theta. X cubed is cubing this whole thing, so this would be what's sin what's 1 times sine theta cubed? It's just sine cubed theta. And the next thing we need is dx. So yeah, let's find dx. So dx is the integration of this. So what's the derivative? What is the derivative of 1 sine theta? It is cosine theta, right? And then all you have to do is get rid of this d theta. So you have dx equals to cosine theta d theta. So now we have everything we need. So now we can just substitute our values. So it's from 0 to 1, and it's 5. And then we said that x cubed is sine cube of theta square root. And then what's 1 minus x squared? It's 1 minus, and we said that we agreed that x squared is sin squared theta. Times it by dx, and we agreed that dx is cosine theta d theta. Okay. So is there any kind of trig substitution we can use? Yes. Do you see this 1 minus sine squared theta? We can use the Pythagorean identity, sine squared theta. Let's go sine squared theta equals to 1. So if I subtract sine squared theta from both sides, you get cosine squared theta equals to 1 minus sine squared theta, right? That's 0 and 1. And then we have 5 sin cube theta. 1 minus sin squared theta is cosine squared theta times it by cosine theta. So this is 0, 1. The square root of cosine squared theta is just regular cosine theta. And then we should simplify it even more. Well, first off, let's take out this constant 5, right? Take that out. And then cosine theta times cosine theta is cosine squared theta d theta. Now, what could we do next? We'll have to use some kind of trig substitution. So what if I rewrote sin cubed as let's rewrite sin cubed theta as sin square theta times it by an extra sin theta, right? That is technically the same thing as sin cubed. And then maybe we should leave the cosine square theta alone. And we still have to take out this 5. So sine square theta times sine, well, now we can use one of our substitution. We can replace sine square theta as 1 minus cosine square theta, right? So that's what I'm going to do. I'm going to replace sine square theta with 1 minus cosine square theta. That's by sine theta. And then you still have this cosine square theta. What to do next? I guess what we can do is use u substitution. And I believe our u would be cosine theta. And then du would be, the derivative of that would be negative sin theta d theta. So will that work? Yes. So that would work out nicely. So 0, 1, 5, and then it's parentheses 1 stays the same. And then we said our u is cosine, so so minus cosine squared theta would be the same thing as minus u square times it by, and then you also have this cosine square theta. So we said u is cosine, so that would be u squared. And then what you're going to do is see how we have we don't need this extra -1. So I have to get rid of that -1 by multiplying both sides by -1. So that's negative du. And then this would be positive sine theta d theta. Okay. So you have time. So you're going to replace sine theta and d theta with negative du. Okay. This is like a -1, so I'm going to take that out. So this would be -5 from 0 to 1. And then we have 1 minus u square, and then du. And then you have 0 to 1, and then you have -5. And then what you're going to do is FOIL out this 1. So this is going to be u squared. And then this would be minus u to the 4th du. And then just take the integration of each of these. So What is the integration of u squared? It is 1/3 u to the 3. What is the integration of negative u to the 4th? It's negative 1/5 u to the 5th. And then don't forget we took out this minus 5, so we have to distribute that. And there won't be a plus c because we have boundaries, right? So let's FOIL out this negative 5, so it's negative 5/3 u 3. And then a negative 5 times negative 1/5 is positive 1, or positive u to the 5. And what did we say our u was? Our u was cosine. So it's cosine cube of theta plus cosine 5th root of theta. Now, is this our final answer? No, because first we have boundaries, and second, our final answer has to be an x. We have theta, right? So before I do my I forget the before I put my boundaries, um you just have to we gotta draw the triangle first. Okay, so here's theta. And what did we say x was? So we were given that x was sine theta, right? So if you do the SOHCAHTOA thing, sine is opposite over hypotenuse. So this x is opposite, and then this one is the hypotenuse. So opposite is x, and then the hypotenuse is 1. So we got to figure out this missing leg in order to find cosine, right? So we're going to do Pythagorean theorem because it is a right triangle. So it's a square. I don't know what this leg is, so I'll just call it a right now. So it's a square. And then my hypotenuse is 1 square, which is just 1. So I'm going to solve for a. So I'm going to subtract x squared from both sides. So I get a squared equals to 1 minus x squared. And then if you take the square root of both sides, you get a equals square root of 1 minus x squared. Okay, so my cosine theta is adjacent over hypotenuse. So my adjacent side is square root of 1 minus x squared. And my hypotenuse is 1. Okay, so now we could try figuring this out. So it's cosine to the third power, or cosine times cosine times cosine. So you can rewrite this as square root of 1 minus x squared. And then we have to raise it to the third power, right? Because, yeah. And then cosine to the 5th power is the same thing as square root of 1 minus x squared raised to the 5th power. Okay. Is this our final answer? No, we have to do the boundaries. So we have to apply the fundamental theorem calculus. So our lower boundary is 0, and then our upper boundary is 1. So let's plug in 1. So this is going to be negative 5/3. And this is good because what's 1 square is 1. And then you subtract that from 1, that's 0. So 0 to the third power is 0. And then the same thing with here. It's 1 minus 1 squared, which is 0, so square root of 0. So this is just 0 minus, and then I'm going to put in my bracket, and then apply the lower boundary. So plug in 0 for x. So it's going to be negative 5/3 square root 1, and then 0 squared is 1, so it's just square root of 1. And then this is raised to the third power plus square root 1 minus 0 squared is 1. And then you have to raise that to the 5th power. Okay. So it's going to be, so over here, 2 minus, wait, let's not do that. So what is the square root of 1 to the 3rd power? That's 1. And then times it by negative 5/3. Plus, what's the square root of 1 to the 5th power? Still 1. So what is negative 5/3 plus 1? I'm not sure. So 1 could be written as 3/3, which is negative 2/3. Okay. So we know that you have, keep in mind you still have this minus, so it's 0 minus a minus 2/3. 2 negatives becomes a positive, so your final answer is 2/3. Okay, so that is your final answer. Okay, so that is the quiz on the trigonometric substitution.